Hi all, 18th May 2025, JEE Advanced. So, we the group of Narayana people immensely worked on the entire question papers. Collectively, we have prepared the final key. And this is the same key, mostly matching with all other competitors across India. Here I am Pawan Kumar Sharma, Physics Faculty and Core Dean for Narayana Group. I am here teaching Physics Paper 2 Advanced. This paper is of 3 sections. First section comprises of 4 single correct answer type. Second section comprises of 4 multiple, and the last section comprises of 8 numerical. Remember, no negative marking. So this is a productively useful paper, useful model for top students. So here we enter into the first section, right? So we have the first question from units and dimensions. Temperature difference can generate EMF in some materials. Okay, fine. Some information. S be the EMF produced per unit temperature difference between the ends of a wire. Sigma the electrical conductivity. K the thermal conductivity of the material of the wire. Some information is given. What they want is, you can see a quantity here. That I will write over here, which is Z is S square sigma by K. They want the dimensions of this quantity. See, you need to do much cleverly in this. The concept of S I can understand as if like volt by temperature. Fine. You know what is the sigma? Reciprocal of resistivity. Reciprocal of resistivity, which means ohm meter units. K, coefficient, what is this? Coefficient of thermal conductivity, basically, right? And the units of this is very clear. This is going to be power by Kelvin, temperature term again, and length meter, right? I'm very basic. I'm doing it in a basic style, basically. Now, please let me know what is sigmas, what is S square sigma by K. We'll just analyze. So, remember, wherever I have volt square by ohm, this can also be taken as power. Don't forget that. Now, basically, let me work on S square sigma. S square sigma is volt square divided by temperature square ohm meter. This can be considered as right. I can assume this as power by, you can see that, power by temperature square into meter. Just stay here. Hello. Next. So what is going to be the S square sigma by K term? Remember, this is power divided by temperature square into M divided by again power divided by temperature into meter. Happy to strike it. Strike it. Make it. Finally, this results temperature inverse. T2, that is k power minus 1 in dimension terminology. Rest all 0. Out of C, this option, no use, done. Question is done. Right. We'll move on to the next question. The next question is on the basis of the Gauss law. You have two coaxial conducting cylinders. You can see that in the diagram. In this diagram, coaxial conducting cylinders of same length L and radii root 2r and 2r. You can see that here. This is root 2r and this is 2r. And here, what you can see is the entire thing is a dielectric material whose dielectric constant is 5. You can imagine a plane that is also given here. That is a plane here, a plane. This plane is parallel to the axis of the cylinder. See, actual cross-sectional view, as if I observe it from the top, I see this. The flux of the electric field through this plane is what they were asking. I try myself, bit good at geometry. I try my level best to be good at geometry. Then I'll close the question comfortably. This is your line. I'll use some other color for this purpose. I'll use some other color for this purpose. Good. Now, coming back, I may label this as A. I may label this as B. And I would like to label this as a C. And this one being D. Now, here is the center. By the way, they have given this distance as R. And you know, we'll take this as some O and this as some A, B, C, D is done. So we'll go with E. Now you see that triangle OEB. OB is root 2R. In this is root 2R and this is R. O, E, A. Boys, 45 degrees. Very simple. Next comes OA. By the way, that is again OA and E. By the way, and this part is 2R and this part is R. So this will be 60 degrees. So therefore, careful study reveals that you have this angle being 45 degrees and this angle being 60 degrees. Remember, this is the first stage of solving the question. Now you come back. You have done almost. Now see, what I am working on this is only through a portion of 15 degrees you want the flux because nothing passed through this. Now therefore, flux through the portion AB, so I'll write over here. Flux through the portion AB is 360 degrees. I would have written Q by K epsilon naught. If it is 360 degrees, you have given me only 15 degrees scope. So therefore, 15 degrees by 360 times Q by K epsilon naught. So what is the phi net? Please see that this is not the only scope. You also have a similar arrangement here. So this will become 2 times 15 by 360 times Q by 5 epsilon naught. Boys, this will lead you to Q by 3 times 6 by 36, so 60 epsilon naught. I've done this. Easy question basically. C is the correct answer for this. If you are not good at geometry, you may miss. Right. So this is a question based on simple harmonic motion actually. You can see the arrangement here. In one case, here you have only difference is configuration. Just a small change in the configuration, and they are asking frequencies. And in fact, I'm thankful to the paper setter ignoring gravity. Very thankful to the paper setter. But I'll take the first case, basically the first case, figure 1. Otherwise, in this case, I am assuming the point O as a pivot here. See, if it hardly turns by a small angle theta, for example, a small angle theta, then here in this case, you will experience a spring force because of the elongation L by 2 theta. So therefore, here the force is F1. I'll write it later. Here also, this portion of the spring gets compressed. Remember, this is elongated and this is compressed. So therefore, this will also experience a force F2, basically. So, right, about O, torques. So net torque about O is F1 L by 2 plus F2 L. Boys, what is F1? F1 is force. What is the force? K L by 2 theta. That is the force. So by the way, you have this one as K L square by 4 theta plus, by the way, what is F2? There the elongation is compression actually. Boys, compression. L theta. So the force is K L theta. So therefore this will become K L square theta. Finally this will become 5 by 4 K L square theta. That is a torque. Here torque is proportional to theta here. Right. By the way, in this case, the force constant term is what we have obtained, torque. The springs are connected. I just want to add one more point. Vertically, two massless springs. Massless springs is also an important criteria in solving this question. If it is not mentioned, we are in trouble. Now see, this is the force constant term. Rest everything is the same. So we will try to see the same situation for the other set. Fortunately, in this set, elongation and compression both are same. So therefore, in the next case, tau O dash case, this will become, both forces are same, almost the same into 2 times. So what you will have is K L square by 2 theta. Remember, my focus is only on this part. And my focus is only on this part. That term will decide. So therefore, what you want is ratio of frequencies. This is nothing but, in first case, 5 by 4 KL square divided by 1 by 2 KL square. Cancel, and this results root 5 by 2. Right. So what options you have is option C, matching for this. A very easy question. See, why we will do mistakes is that in the process of rush, we will compromise with the fundamental calculations. Please don't do that. Right. We'll move on to the next question. The next question. See, lot of discussion happened related to this question. I am trying in this way. The major of our teaching community and our experts team suggested this, so I am proceeding in the same manner as per our Narayana core team. Right. Let us see at any instant what is happening. At any instant. At any instant, you have G M1 M2 by R square. What is, we are assuming one star as of mass M1, the other star as of mass M2, right? And here one is moving around the other. M2 Kg1, which is a lighter one, is moving around M1. So the heavier star slowly acquires mass from, it is like, see, in astronomy, they will show one black hole swallowing another one, something like this. A similar situation. The lighter one is losing mass at this rate. They have given clearly rate of gamma kg per second. Like clearly mentioned. Now the question is, at any given instant, it's in motion around it, right? Circular motion, I assume. Then this should be M2 V square by R must satisfy. And remember, this is a central force system. Gravitational force is a central force system. Under the influence of central force, angular momentum is conserved. So therefore, I am converting this into an angular momentum term. So therefore, that allows me M2 V square R square. Now you believe that this is an angular momentum term. So you should not compromise like this, you know. So to justify this, I require M2 R cube. So I have converted this form, the second term, to the third term. So now this you can comfortably write as L square by M2 R cube. Boss, till this point, I am still at a fundamental approach. I did not compromise any of the fundamentals till the step. Now the question is, let us try to see what is there available for me. M1, M2 square, R. Balance L square by G. Why have I isolated L square by G? Probably you would have got my meaning. That's a constant. What happens to R, what happens to M2 or whatever happens to M1, right side is a constant. And it's a slow process. As my understanding, it's a slow process, losing it at a slower rate. Then what happens is just do differentiation of this. So this you will get as dm1 by dt times 1 by m1 plus 2 times, okay, dm2 by dt times 1 by m2 plus dr by dt is equal to 0. Right. So what is dm1 by dt? They see what is that they are giving earlier. See, try to please understand. I am losing at a rate of kg per second. The other end is receiving at a rate of kg per second. This is my understanding, and that's how I have done this question. Right. So ambiguity lies here only. Basically, till here, every physics teacher is in unison with our understanding. Whereas after this step only, there is some ambiguity. So I am assuming the question is correct. IIT professor have properly selected this question. I am assuming like that as of now. So therefore, I am assuming the entire thing as gamma by m1, and there is 1 by r term also here. dr by dt 1 by r, right. Now in the process of doing all this, gamma by m1 minus 2 gamma by m2, why I put minus is one is gaining, the other is losing, plus 1 by r dr by dt is equal to 0. So, okay, restructuring this properly, I'm just writing over here 1 by r dr by dt is 2 gamma by m2 minus gamma by m1. See, they have uttered one term. What is that term? M1. Here, hello. They have uttered the term. It's not me. They have uttered the term. M1 much greater than M2. So therefore, in that case, 1 by M2 much greater than 1 by M1. So I am simply ignoring this term, and this is 2 times gamma by M2. Right. So therefore, my answer is this. This is how I am assuming. Right. The only thing that I have compromised is this substitution part. Next. So here ends the section 1 of the question paper. Now we are moving on to section 2, multi-correct answer type questions. Right. Here you have the question, please. You have a positive charge whose magnitude is 10 to the power of minus 8 C. Is kept at a distance of 20 centimeters from the center of a neutral conducting sphere of radius 10 centimeters. Right. The sphere is then grounded and the charge on the sphere is measured. The grounding is then removed, first grounded. Charge will flow from ground onto the conducting sphere. And now you are removing the earthening part. Means you are disconnecting it from the earth. And subsequently the point charge earlier, which was supposed to be at a distance of 20 centimeters from the center of the conducting cell, is no longer at that point. It is now at 30 centimeters from the center. You have taken 1 by 4 pi epsilon naught value, all that they have given, fortunately. Then you have some options. What is happening in this question? Let me work step by step. Multi-correct answer, remember. Now see, I am taking the arrangement as, here is your conducting, whatever, what is that? Conducting sphere, in fact. And you have the charge here, Q. And this distance is technically 20 centimeters. And the radius is 10 centimeters. Now we will go with first option. The first option, at this point, the potential is under first condition, strictly 1 by 4 pi epsilon naught q by whatever the distance, that is 0.2. So by proper substitution, I have done all that substitution, 1 by 4 pi epsilon naught q, all that. I am getting the answer as 450 volt. Boys, 450 volts. So first option is absolutely correct. Next. Remember, when you are connecting it to the ground, to make this zero potential, some charge will flow on to this, let that be some Q dash. Okay? Already your Q is still available here. So this combination should result in zero potential. So therefore, K Q dash by radius 0.1 plus K Q by 0.2. This should result 0. Now this relation allows you to write Q dash as a minus Q by 2. So which means in this you took this as a 10 into, correct it as 10 into 10 power minus 9 coulomb. Obviously this is 5 into 10 power minus 9 coulomb. And please don't confuse here. Earlier there is no charge on the conducting sphere. Now there is a negative charge. Now what is happening? If there is a negative charge on that, certain amount of equivalent positive charge must flow from that conducting sphere onto the earth. So a lot of students will do a mistake by leaving this option. You should not leave this option. So correct. After grounding is removed, the net charge, when you are correct in B, you will be correct in C. Right. The final electrostatic potential of the sphere is, remember, if everything is same, 0 I would have written, but you have disturbed that point charge. Now what is happening is, at the center, now you will have kq dash by 0.1 plus kq by 0.3. This you need to calculate. I have done that calculation. I got around minus 150, which is nowhere matching with this. Nowhere matching with this. Right. Fifth question, easy question. First multi-correct answer type question is, of course, a very easy question. Next comes optics. Every year there will be a question from ray optics, lens combination, lens concave mirror combination, concave mirror combination. This year also they followed the same trend. Right. You have two identical concave mirrors. You see, both they are of same focal length and facing each other as shown in the diagram. Focal length f is much larger than the size of the mirrors. A glass slab of thickness T and whose refractive index is n0 is kept equidistant from the mirrors and perpendicular to their common principal axis. A monochromatic point, you can see that point light source is embedded at the center of the, you can treat that as your object was. Which of the following distances between the two mirrors are correct? I'll forget all these things and I assume that only one concave mirror, and I assume that the effective position of that object as seen by an observer here is at the center of curvature, which means already what they have given, this is D and T. In fact, the centers are separated by 2D plus T, right? So if I am here, standing here, I see that for this location to be my center of curvature, what should be the correct distance? D plus, okay, right. Now it is exactly the middle, which means for this observer who is standing over here, for this observer, the apparent depth from the free surface is T by 2 mu, refractive index, T by 2 times n0. And remember, that should be the center of curvature location, which is nothing but 2f. So what is satisfied here is, for which of the following distances between the two mirrors is correct? They want 2D plus. See, I am assuming this as my first option. If this is my first option, what is going to happen is D is equal to 2f minus T by 2 n0. Right. Now what do you want actually? You want practically 2 times D plus T by 2, that is the actual distance. So just to substitute that, you will get this value as 4f minus T by n0 plus T. Otherwise, 4f plus T times 1 minus 1 by n naught. Boys and girls. Option 4, option A, absolutely fit for this. Now the question is this the only possibility? Is this the only possibility? I'll just tell you a simple story. Suppose, forget about the glass slab and all that, boss. Now you have the object here, okay? Exactly the focus. What happens? Rays will go like this and come out parallelly and again form over here only. You want the same condition. So now my next target is very clear. D plus T by 2n naught is F. That is also possible. Now do everything same process. You know, in this case, you will get 2D plus T as, in this case, 2D plus T as 2F plus 2F plus 2F plus T into 1 minus 1 by n naught. And that satisfies option B. Lot of discussions happened. Initially, lot of faculty suggested only A as option. This is also possible. In fact, last year also a similar situation was faced by the students. And there are 3 options. There is a numerical question basically. 3 options they have given. 3 different values they have given. So therefore, it's a multi-correct answer type. Don't stop with A. Check for all possibilities. Next, we are moving on to the next question. And this question, a very simple question actually. But see the size of the question. A lot of pleats and all that will make you afraid of. But actually, it's a simple question according to me. See how the way I do this question. Okay, basically, what is the question? You can see 6 infinitely large and thin non-conducting sheets which are fixed in 2 different configurations. Configuration 1, configuration 2. Right. And okay, what are the charges per unit area and all that they have mentioned. Right. Straight away get into the concept. The only one thing that I will use for the later purpose is that this value of sigma naught and the distance between the plates also they have mentioned as 1 micrometer. That 2 entries I will use it later. Suppose I am a good student and I don't have time. I just want to close this in single instant. Then go for option A. Boys, option A in region 4, the configuration of one of region 4, I mean this part. The magnitude of the electric field is 0. How the way I operate this, I will explain. Allow me please to change my color of my pen. Arey, you want to focus over here, right? Pakka here, right? Let me take this portion separately and let me take this portion separately. Boys and girls, what is the net enclosed in that? 0. Net charge enclosed is 0. What is the net charge enclosed in that? 0. I see that there are 2 plates without any charge. So what will be the electric field there? 0. So therefore, first option is absolutely correct. Next, in the region 3 of the configuration 2, region 3 means here at this point, the magnitude of the electric field is, hold on, no issues. In configuration 3, for example, I will rewrite configuration 2 properly. I will rewrite the configuration 2 properly because this one I am not convinced actually. So I will write the configuration again. This is the first plate. This is the second plate. This is the third plate. This is the fourth plate. 1 minute. 1, 2, 3, 4, 5, 6. 6 plates I need to draw. Fifth plate, sixth plate. Yes. To avoid confusion, I'll change the color of my pen again. Practically the net charge of this system is 0. You may ask me how. cancel, 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 cancel. Right. So all the charge distributions will be like this. Sigma naught by 2 minus sigma naught by 2, right, minus sigma naught by 2 plus sigma naught by 2, right. Okay, earlier I am dealing with this plate, this plate. So therefore this should be sigma naught by 2 minus sigma naught by 2, right, minus sigma naught by 2 plus sigma naught by 2 plus sigma naught by 2 minus sigma naught by 2. That's the deal. Okay, right. Now the question is, boys, in this situation, this is how you have the electric field, and this is how you have the electric field. This is how you have the electric field. This is how you have the electric field, and finally this is how you have the electric field. Very direction. Don't forget, in the region 3 means here, What is the field? Simply here the field is E is equal to sigma naught by 2 epsilon naught. But whereas you have given the answer as sigma naught by epsilon naught. So which is a wrong option. Similarly, potential difference between the first and the last plate of the configuration 1. Configuration 1 is a very clean hit concept. See, remember, you will have the arrangements like this. See, entire field will be here rightwards, left to right in this zone, and no charges in this region, 0. And again thereafter, again you will have an arrangement like this, and again you will have an arrangement like this. That's the deal. What is that they are asking? The potential difference between the first and the last plate of this configuration, right? No issues. You want to operate here, no? Here this is 0 again. Simple. I am working on configuration on potential difference. See, the configuration 1 potential difference is simply ED, E1 D1 plus, E2 D2 plus, E3 D3 plus. Likewise, you will apply, right? Okay. Now, in this case, it is sigma naught by epsilon naught times D plus 0, sigma naught by epsilon D plus 0, sigma naught by epsilon naught D. That's it. So you have 3 times of this. 3 times sigma naught by epsilon naught D. I have solved that, and this value is going to be 3 volts. Whereas the option what they have given is 5 volts, which is wrong. Next, the potential difference between the first and the last units of the configuration 2 is 0. No, not at all. Why? I will explain. Maybe this cancel. Yes. This one and this one cancel. Yes. But one thing is left. Basically, if you draw the PD formula across these 2 plates in the same way, you will have one arrangement. Actually, in the second case, the potential difference becomes delta V is equal to sigma naught by 2 epsilon naught D. That's what you will have. By solving which I got 0.5 volts. Actually, sigma naught by epsilon naught into D gives 1 volt. So half of that, 0.5 volts. You said 0, which is wrong. Remember, a comfortable question. Suppose if you are unable to opt B, C, D, at least you can comfortably solve A. Just it's a theory question by that time. At that time, you may feel like answering only 1 mark. By the time when you come out and see the original key given, got 4 marks. But by doing a mistake of selecting any other option, you are missing a huge margin. Please. Next question. Next question is on the basis of a Carnot's engine. As per my understanding, over years of my teaching, not less than at least 29, 30 years, it's a more or less a mains type question. I'm telling you, direct mains type question. Yeah, we'll go into the question. The efficiency of a Carnot engine operating with a hot reservoir kept at a temperature of 1000 Kelvin. 1000 Kelvin is 0.4. Hold on. It extracts 150 joules of heat per cycle. Very important data. Even this is also a very important data for me from the hot reservoir. The work extracted from this engine is fully used to run a heat pump. Heat pump, which has, for a heat pump we will define coefficient of performance, right? For a Carnot engine we will define efficiency. They are two different things. Like a automobile, just giving sample, an automobile engine and a refrigerator type. The hot reservoir of this heat pump is at a temperature of 300 Kelvin. Which of the following statement is or correct? Let me try to first analyze this properly. A detailed analysis is required for me. Now I am assuming it like this. Right, you have 1000 Kelvin and here is your engine, and this is a drawing how much. Just clear it. Extracts 150 joules of heat cycle from the hot reservoir. Hot reservoir, right? This is a hot reservoir. T hot, right? And it is a drawing how much? Literally, you are drawing 150 joules, right? And you will reject it to sink. I don't know the temperature of the sink. T cold otherwise. And one more important point is also required. You want to calculate that work part also. Besides, let me first use what is given over here. Coefficient of performance part, efficiency part, 0.4. So in what way? I'll just change the color of my pen so as to give you some more clarity. You may not confuse here with the data. 1 minus T cold by T hot is 0.4. So therefore T cold is T hot times 0.4. 0.4 nahi, 0.6. 1 minus 0.4. 1 minus 0.4 is what available over here. So therefore this is 0.6. So this works as 1000 into 0.6. 600 Kelvin. Let me see, am I going to benefit anything? Yeah, come on. One option, right. Work extracted from the Carnot's engine in one cycle is, see, work extracted. That's what you want, right? Chalo. How to calculate that work extracted part? You have the efficiency formula here itself, no? You have the efficiency formula. How much you have taken? 150 into 0.4. Or here one more definition, no? Work extracted by taken in is also eta. Therefore, work extracted by 0.4 times 150. That is 60 joules. Yes, 60 joules. So I've done two options out of this. Right. This is a normal mains question. Till this point. Whatever it may be, 2 marks, I got it already. Okay, for example, whether CD options are there or not makes no difference for me. AVA to pakka. This very short. Right. Now we will go on to the next part. Now this 60 joules is taken by the pump, heat pump, and some Q1 is drawn from a T lower side and which is given to TH side, right. And you have given that this temperature is 300. The hot reservoir of the heat pump. This is the hot reservoir of the heat pump. 300 Kelvin. You already have given this, right? And you have given Q1, right? And you are drawing your what do you call? There is one thing. The work extracted is 60. Can you please help me in writing the coefficient of performance in the way how I have written two different definitions here? Here also you can write this as Q1 by W 60, and this is given as 10. So Q1 is 600 joules. Hold on. So therefore, what is a Q2? Are here Q1 from this side, Q2 from 60 joules from this side. So Q2 becomes 600 plus 60, 660 joules. Wow, wrong. Next, and one more important definition of coefficient of performance is TH by TH minus TL is 10, that they have given, and you have given TH for me, which allows me to calculate TC, this one, TC as 270 Kelvin. So therefore this is correct. Remember, this particular formula and this particular formula both are mains level only, direct substitution. Even this is also direct substitution. The only thing that you may miss is to judge this. Otherwise, all three are mains options only. Fortunately, this is wrong. So even if you trust your same old mains knowledge of solving this question, done. You got 4 marks. Right. So we are moving on to the next question. Now I have entered into numerical stage. Remember, first section is done single correct answer type. Next section is also done multi correct answer type. And now the last section is the numerical type. Right. You go with the first, the question that deals with magnetics. A conducting solid sphere of radius r and mass m carries a charge q. The sphere is rotating about an axis passing through its center with an angular speed omega. The ratio of magnitudes of the magnetic dipole moment to the angular momentum about the same axis is given as some alpha times q by 2m. Lot of people will do one mistake here. That I will explain clearly. See, one assumption that you should feel here is whether it is a shell or whether it is a conducting shell. Both the cases, the charge will be on the surface only. So M refers to same in both the cases. If you ask me the same question, in case of what you call a solid shell, a solid sphere otherwise, M solid sphere by L solid sphere, you can write it as M the shell by conducting shell by L solid sphere. Remember, I know M of shell part. M shell part by L shell part is comfortably q by 2m. Undoubtedly, there is no mistake in this. M. And remember, this is nothing but M shell part is nothing but 2 by 3 mr square some omega angular momentum term times q by 2m. Right. Keep this aside. Now we will work on in the same way. You have this 2 by 3 term mr square omega q by 2 times capital M. Right. Solid moment of inertia is different. So 2 by 5 mr square omega. Actually, they are asking you this. mss by lss is simply 5 by 3 times of your answer is 5 by 3 because it is numerical type 1.66 or 1.67. Anything will be the answer for this. 1.66 to 1.67. Anything is an answer for this. You put any of these, you will get the answer right. Very simple question. Confusion is there. Some people may go with 2 by 3 also, they will fail. Some people will go with 2 by 3, they will fail. So therefore, even though it is non-negative marking, certain traps were installed in this question. Next, we will move on to the next question. An hydrogen atom initially at rest in its ground state. Fine. He absorbs a photon of frequency nu1, right, and ejects the electron with a kinetic energy of 10 electrons. Stop. Let me analyze this. So the corresponding energy, if you allow me to write, the corresponding energy, if you allow me to write, this is nothing but 13.6 plus whatever excess you said, that's in the form of kinetic energy. So that is 10 electron volts. Totally, this is 23.6 electron volts. Proceed further. The electron then combines with a positron at rest. You know, both are of same mass, charge-wise opposite polarity, to form a positronium atom in its ground state and simultaneously emits a photon of frequency nu2. The center of mass of the resulting system, positronium atom, can be considered as a Bohr atom, in which, okay, the electron and the positron orbit around their center of mass. Consider no other changes, no other energy losses during the whole process. The difference between the two photon energies is. Let me try to understand. What you have is this 10 electron volts only outside. Now what is happening to this 10 electron volts? Let me please change the color of my pen for the second part of my calculation. Now what is happening now? Just please focus on this calculation part, because first part everyone will reach. Second part only you will face a problem. Now what is happening is this 10 electron volt which you are receiving is distributed as one kinetic energy of center of mass plus that ground state energy, binding energy otherwise, E ground state plus E2. That is the energy where you got at a photon. Now, data is important for you right now. The center of mass of the resulting positronium atom moves with a kinetic energy of 5 electron volts. That's given to you clearly. Next, one more important point. See, what about EG part of that? EG part of that will become half of 13.6 actually. You know that. So therefore, E2 will become 10 electron volts minus 5 electron volts, right? And actually this is a minus 13.6 by 2. So this will become plus 6.8. So overall this will become 11.8 electron volts, right? That is E2. And by the way, what is E1? 13.6 electron volts. You are asking the difference between the photon energies. E1 minus E2 is 23.6 minus 11.8. That works around again 11.8 electron volts for you. I am telling you again, the source of mistake that you people do is this part. Only for that proper data was not given, and you need to have the knowledge from your previous practice process. Okay? So I am repeating again, it's a very good question. But traps traps were set. This is where our grand tests, Narayana grand tests, Narayana revision program, Narayana assignments, all that helps the students. Right. 11th question. So, similarly, 11th question is also from HEAT, a general graph based question. Every year you will face one graph based question. One such question is this. And this is a repeated n number of times in our grand test. Ideal monoatomic gas of n moles is taken through a cycle. See, let me try to explain what is happening. It's a VT graph basically. Okay, which means any process from X to Y is isobaric, pressure constant, because it is passing through the origin. The line is passing through the origin. So therefore, in any time I can use this relation Tx by Ty at any time can be written as equal to Vx by Vy. I will use at any time less one. By the way, you have given volumes Vw, Vx, Vy. That's all. That is also mentioned in the question. Let me write that data also properly. I'll write over here. No issues. So V at W is given, which is 64 centimeter cube. Vx is also given, which is 125 centimeter cube. Vy is also given, which is 250 centimeter cube. Remember, Vx, Vy is given. We have Vx by Vy here. So therefore, this you can write it as Vx by Vy 1:2. So wherever I have Ty, I will write 2Tx. Remember, this is a very crucial observation in my next stage processing of the question. Right. Now let us get into the question much more deeper. What do you want? The amount of heat absorbed in the process. Right. Wait. See, one point is very clear. There is another process also involved here, which is W to X. So clearly, allow me to use a different color. W to X is adiabatic. Since it is an adiabatic process, Tv power gamma minus 1 is equal to constant, you can write. Here gamma is, what is the gas? The gas is monoatomic. So gamma is 5/3. Gamma minus 1 is 2/3. So if I compare pressures, temperature, Tv power gamma minus 1 is equal to constant. Tw xw to the power of Vx Tw V at W to the power of 2/3 is Tx Vx to the power of 2/3. That's the deal. Tw. Why I am fascinated with these numbers? Because I have numbers W, Vw, Vx. I have numbers. I need to make use of that. 64 to the power of 2/3 is equal to Tx Vx to the power of 2 by 3. 125 to the power of 2 by 3. See, after proper calculations, you will arrive to Tx as Tw times 16 by 25. Remember, this is also one relation which I might use it at a later stage. Similarly, x2y data I have, everything I have, right? Now, by the way, what you want in this question? What exactly you want? The amount of heat absorbed by the gas along the path xy. Hold on. Remember, actually this is an easy question. Just some game with the data. So, in an isobaric process, you said it is from xy. Q xy is simply NCP dt, delta T. So, Ty minus Tx. Number of moles, N moles, Cp 5 by 2R. Don't forget, wherever I Ty, I can use 2Tx. So, therefore, 2Tx minus Tx, and that is N times 5 by 2R Tx. Who cares for this? We want the answer to be expressed in the terminology of TW. That's what he is expecting. Why? Because, see this question, you can use this value. So, where do I link Tx with TW? Here you have. So, which means Qxy can be written as N into 5 by 2R into Tx, 16 by 25 times TW. Boys and girls, done. You have 8 by 5 times of N R TW. NR TW, they are given as 1 in the data. You can see that. You see here. So, I will substitute 1 joule, and finally what will happen is this will be 8 by 5, 1.6 is going to be the answer for this. 1.6 joule. A very good question. We will move on to the next question. See here, it is a geostationary satellite above the equator is orbiting. The first one is itself geostationary. So, which means wherever I have 2 pi by omega 1, that is nothing but 24 hours, because the first one is taken as geostationary. Fine. You took another satellite which is moving in the opposite direction. It's given in the question at a distance r2, and you have given a relation between r1 and r2. Means you can give some relation between t1 and t2, which means you already know t square is proportional to r cube. T1 square by T2 square is R1 cube by R2 cube. T1 by T2 is given as, see, find that R1 by R2 is 1.21. 1.21 is nothing but 1.1 square. 1.1 square is 1.21. So, this is 1.1 whole square to the power of 3 by 2. This results in 1.1 whole cube will result in nearly 1.33. Nearly. Remember, T1 by T2, otherwise also called as omega 2 by omega 1, is 1.33. Hold on. What do you want? Time period of 2 with respect to 1. What you want is 2 pi by omega relative. Since they are moving in opposite direction, you will write it like this. T relative. And this is 2 pi by, you got a relation, no? Omega 2 has 1.33 omega 1. So therefore, you can make it as a 2.33 omega 1. Remember, wherever you have 2 pi by omega 1, I will write it as 24. So 24 by 2.33. What do you want? Your answer to be expressed as 24 by p hours. Therefore, p is nothing but 2.33. That is your answer. Okay? A very important question. Read the question carefully. The left and right compartments of a thermally isolated container of length L are separated by a thermally conducting. What does this refers to? Thermally conducting means left hand side, right hand side, temperature is maintained the same in equilibrium. Right. The left and right compartments are filled with left side 3 by 2 moles, right side 1 mole of an ideal gas, right, respectively. In the left compartment, the piston is attached by a spring with spring constant K. Remember, the natural length of the spring is 2L by 5, means 0.4 L. Now, in the diagram, they are showing L by 2, means the spring is elongated already, right. In thermodynamic equilibrium, the piston is at a distance of L by 2 from the left and right edges of the container as shown in the figure. So, in the equilibrium state, the spring is elongated, right. And elongation in the spring is simply L by 2 minus how much? 2L by 5. This is nothing but L by 10. That's the elongation, right. Now, if I take the free body diagram of the piston, for example, if I take the free body diagram of the piston like this, so from the right side, you have P2A force. Spring also pulls this with F force, and the left side gas will exert a force P1A. Right. So this allows me to write P1 is nothing but P2 plus force KL by 10 by A. Stay there. P1, we have number of moles also, no? 3 by 2 RT by V is equal to, right side you said there is only 1 mole. 1 mole. So therefore, you have RT, 1 RT by V. Don't ask me why temperatures are same. I told you very clearly. It's a conducting piston. Plus KL by A into 10. Right. Now you solve this. What exactly is volume? Wherever you have volume, you can simply write A into what is volume? Volume each side. A into L by 2. That is also there. So by substituting all that in this part in this, you will come across a condition that R into T can be written as KL square by 10. Okay, KL square by 10. Right, let it be. What do you want basically? You want the pressure in the right compartment. What exactly is the pressure in the right compartment? The pressure in the right compartment is given as, right compartment you have only one volume, 1 mole, or T by volume. Volume is A into L by 2. Right. Just now I have derived RT, which is K L square by 10 divided by A into L by 2. So finally this can be written as K into L by A times 1 by 5. See, in the place of alpha you have 1 by 5. Right? So therefore the value alpha is 1 by 5.2. Absolutely correct. Very simple question. See, lot of practice areas we have given during our grand test here. So therefore this is a simple question when compared to all those spring heater. In fact, we have added heater also in that chamber where we are connecting the spring and all that. So very simple question. And next comes, this is question number 13. Yeah, question number 14. See, for a question number 14, a detailed study is required for every student. It's not at all a difficult question. Detailed study, every line to line you need to read the question. In Young's double-slit experiment, a combination of two glasses, you have wedges actually, A and B having refractive indices 1.7 and 1.5 respectively, are placed in front of the slates as shown in the figure. I'll zoom it up later on. Right. Now they have given the values for small d, capital D, all that. The thickness of the combination is 12 micrometer. Right. No issues. The value of L as shown in the figure is 1 mm. What is L? Yeah, L is 1 mm. Right. This is why they have given this data is important for us. Really important for us. For example, if I study this wedge like this, for example, I'll change the color. You can identify or distinguish two prisms over here. See, please try to understand. You said that this exactly, the total part is 12 mm. Right. Now, please try to understand D is 2 mm. The D part is 12 mm. 2 mm, sorry. Means these 2 points are separated by 2 mm. Above you have 1 mm, below you have 1 mm. I repeat, above you have 1 mm, below you have 1 mm, in between you have 2 mm. So, now please try to understand in this process what will happen is the division part. Now, the total 12 is divided across accordingly like this, which means at this point you will face 9 mm and at this part you will face 3 mm. Similarly, at this part you will face 3 mm and the remaining part you will face 9 mm. But remember, the refractive index of these portions are different. One is 1.7 and the other one is 1. Now I am taking this as a B for a while and this one as A for a while. This is the very first step that every student need to identify. Rest everything is the same. Remember, I see that these are two different, what do you call, sheets, mica sheets, like in two different sheets, right? So how the way that they are producing path difference, that I will work right now. Now I am calculating the path difference part like this. I'll use some other space here. I'll use some other space here. Yeah, I'll use this space. In that particular question, when I am choosing two portions like this, so which means you take this as S1, you take this as S2, material B, material A. Remember here I just mentioned the thickness part is 3 mm followed by 9 mm. Here it is a 9 mm, 3 mm. Same thing you can have here. 3, this is a 9 mm and this is 3 mm. I took as if like two sheets. Now I am calculating path difference. Remember, 3 times mu B plus 9 times mu A minus 12 is the effective path difference produced here. Similarly, lower side also you have some path difference. Mu B times 9 plus mu A times 3 minus 12. That's the effective path difference. Earlier you used to write mu minus 1 into T. But here combinations are there. That's all. Now this will become minus 6 times. After doing the proper calculation here, you will have minus 6 times mu B plus 6 times mu A. And this works out to be 6 times mu A minus mu B. Right. They have given the values 1.7, 1.5. So obviously you will get this as 1.2 times of 10 power minus 6 meter. Don't forget, you will write d sin theta as the path difference, which means d times y by capital D is delta x. With this, I will get y as d by small d times delta x, and I will substitute the values here. D is given 2 meters and it is 1.2 into 10 power minus 6 divided by d 2 millimeter 10 power minus 3. So I will work this and I got it as 1.2 millimeter. Remember, it's very simple. Only thing that you need to do, don't forget, whatever that is placed, it is immaterial for you, by prism or whatever it is. Immaterial. Why they have given that data is important for you. In fact, you can solve this very comfortably. But during the time of examination, the pressure dominates on you and you will fail in identifying the data. So the answer for this is 1.2 mm. It's a perfect number. Next, 15th question. Last but one question actually. A projectile of mass 200 grams is launched in a viscous medium of angle at an angle 60 degrees with the initial velocity of 270 meter per second. It experiences a viscous drag. Constants are also given. C value is also given. V refers to instantaneous velocity of the projectile actually. You take E as 2.7, no issues. What they want is the horizontal distance of the wall from the point of projection. What is at an instant V bar? At an instant V bar refers to V bar is equal to Vx I cap plus V by J. I am assuming it like this. So what is F bar in that case? So F bar in that case is C, which is 0.1 times V x I cap plus V y j cap. And not only that, this is not the only force, you will have weight also in the picture. This is the net force, and from this I will get acceleration also. What is the mass, by the way? 200 grams. So acceleration is nothing but minus 0.1 by minus 0.2 actually. Literally this is 1 by 2, which means minus Vx by 2 I cap, okay, minus Vy by 2 plus minus Vy by 2 plus G times J cap. That's A bar, acceleration vector. This is the basic data that we have. Now we study differently. You want basically what is the x coordinate? Wall refers to x coordinate. That too you asked where horizontal distance of the wall from the point of projection. So you want x value, right? Fine, no issues. So if you allow me this A bar term, you can write it as dvx by dt is minus Vx by 2. No issues. From this I can write dvx by Vx is minus dt by 2. Any other information? 2 seconds you mentioned, right? Initially projected with 270 meter per second and angle is 60 degrees, which means half of that is ux. What is ux? Half of that. Why? 270 cos 60. 135. 135, right? Meter per second. So therefore this is initial. So I have done the proper integration between 0 to 2 seconds. So what I got in this is V by Ux is minus V by Ux is e power minus t by 2. So you have V as, in fact Vx as Ux times e power minus t by 2. And they are not asking about this. And they are asking about x. So you need to show one more round of your patience in working on this part. Ux e power minus t by 2. So by doing the proper integration, you will get the condition for x as 135 times. I have substituted all that integration part and all that, minus 2 times minus 1 plus e power minus 1. So write this properly. X is equal to 135 into 2 into 1 minus 1 by e. So they have given the proper values for e and all that. So just to substitute, you will get the answer. 135 into 2 is 270, and what do you call 1 minus e minus 1 point e minus 1 1.7 by 2.7. Good numbers. I told you IIT will never disappoint with the numbers. Good numbers there. So you will get the answer as 170 meter. So maximum x, that is our distance from the wall. The horizontal distance of the wall from the point of projection. That's what they are asking. That I have solved. 2 times integration is required in this question. Well, by this time you are habituated for this. Next question and the last question. An audio transmitter T and a receiver R are hung vertically from 2 identical massless strings of length 8 meter with their pivots well separated. You can see that. Well separated along the x-axis by a small angular amplitude. Amplitude is also given, a small amplitude. And released simultaneously. Basically, what will happen is they will oscillate like this. Like this. They have given speed of sound in air and all that. Fine. By the way, when this arrangement comes over to here, it will have a maximum velocity here. Maximum velocity. So that maximum velocity, you can write it as, under root 2GL 1 minus cos theta, which is under root 2 into 10 into 8 into 1 minus cos theta. They mentioned 0.9 cos theta. This will become 0.1. Almost this will become 4 meter per second. Right. Forget about mechanical part. Now it is like, see, if this is a source, this is observer, source moving towards observer give maximum frequency condition. And that condition is F max is F naught, okay, speed of sound in air, okay, speed of sound C plus V observer by C minus V source. Fortunately, you need to take these maximum values. VO, VS, maximum values you need to take. Max. Similarly, what is F minimum? F minimum is that condition where moves away like this. So therefore, F minimum is F naught, C minus V naught max by C plus max. By the way, what do you want? You want the difference between these two. So F max minus F minimum. Just do the calculation. Laborious calculation undoubtedly you will get, by doing which I got it as F naught times 4C. Remember, V naught max or V source max, anything is 4 meter per second. So therefore, that I am writing it as some V for convenience, by C square minus V square. So by solving this, I got nearly 32 H. Right. See, as per my observation, out of all the numericals which I have done now, the 8 numericals, only this is the problem where I faced some calculation. Remember, for this question, undoubtedly IIT people will give certain range. I am assuming the range somewhere between 31 to 33, or sometimes if it is okay, 31 to 34, something like that they will give. So don't worry. But at least this, till this part you can reach comfortably. So this is all about paper 2 physics. I wish you would have scored definitely well. Undoubtedly, Narayana students will do well because most of the questions in these models already covered in our grand test. Thank you all.